So today I'll try to prove what I call the um, uh, uh, I'm trying to use functional programming. Uh, I call it the I'm trying to prove isotrophism in using a functional programming paradigm. Functional programming paradigm. There's already a framework that works for uh, this instruction set, but I will start with the concept to avoid why I'm trying to make this proof. Why am I trying to make this proof, Namdi? So this proof is actually isotrophism, what I call sequential isotrophism. Because isotrophism for MMUCO Orion, this is the first proof to start with. So what is isotrophism? So isotrophic ism. Let me just Google it here first because I don't want to make a mistake. Isotrophic isotrophism. The In British English, basically this is a computer term, but I'm trying to use them to describe the one I'm doing here. So the formal definition of isotrophism is literally the property of having a uniform physical property in all directions. The properties of having uniformity, like in physical properties in all directions. Yeah. So this is an associative proof. What am I going to demonstrate here? I'm try and demonstrate it pragmatically with alpha and beta reduction as a form of alpha and beta computational reduction, which is a lambda calculus. A lambda calculus uses alpha and beta to reduce problems that are used to solve in the used to solve easy to solve because they are basically I have to find out what that means because I can't remember. I know what I'm talking about, but I can't remember the terminology. So the physical properties are so the physical properties are isotrophic, and they can be reduced with alpha and beta reduction. So alpha, let's go alpha and beta reduction, which is programming. Alpha to come. Okay, so basically these problems can be the language can be also basically language can be defined as basically alpha renames bound variables to reduce void conflict while base reduction applies functions to arguments by substituting them with expressions. So I can't prove this, but I can prove this to some degree. I can state this, make it claim to some degree, but I can't really prove it. So okay, alpha renames bound variables to avoid conflicts, and beta substitutes argument into function models to compute results. So this is a beta reduction proof. Yeah. So yeah, but the same proof we can use the alpha to solve it. What do I mean? Okay. So take the touch command. The touch command can be expressed as a simple branching algorithm. The touch command can be expressed as a simple branching algorithm. So when you program touch, T for tango, U for O for orange, U for umbrella, C for Charlie, H for hat. The program touch is used to create a file in a Unix system, like touch file name. So touch file name, just that the file name dot c. Let's say file name dot txt. I don't like the simplify this because it comes to applies. Now, touch is a program. Now, the program has a language. So if you have if file name or if if inputs or if arg1 if not arg1 create the file. So basically basically how do you create files in basically if file the two branches are if the file does not exist, if file name, if not file. Basically, this is a real principle, like reduce if file, if not file is null. If you can check whether it's null. I have to remember how to call it. I'm doing this very poorly, but I'm doing this anyway because I have to do my own. So if file uh if not file basically or if file equals null or equals null, you know, because if basically this is not even a good competition algorithm. So let's declare it properly. Let's do that as a simple algorithm. Let basically let me just show you. See, no, let me use Python. Uh, file name equals def basically if the file doesn't exist, you create a file. You know that's simple. And so if there are two branches, if the file exists, uh you open it. Wait, you create it. If the file doesn't exist, let me just try in Linux because I can't remember how this command works. So it's funny. So if the file does not exist, you create it. If it does exist, print file organizer. So let me try that because I'm trying to find out the next equivalent of it. Let me just try it here. Touch means create. So basically, I'm gonna use the concept, uh, very, very. I don't know how to put it. Like, basically, if because no one took it seriously, only people like me will take it seriously. Okay, so the idea is you have the branches, but the branches of code are instruction set you can execute. So you can call that instruction set because there's the alpha and beta isomorphism alpha and beta reduction and isotrophism exist. I'm going to just put it out there because I'm not in the concept. I'm not in the concept. So the idea. Let me just give you an example. For example, without the code. So file dot dat touch file. This is file dot dat. This is another example. This is data. This is a touch file. So the touch is the program, file is the file name, dot dat is the data. You know. So this will create the program. This can mean start. This can be a state of start. Of launch the program. So this can be launching the program. I don't want to be generic. I want to be like a cinematic figure. Cinematic figure. Gonna have alpha reduction and alpha isotrophism. So if touch creates the file, create this process without explicitly saying create this process. It can basically basically the touch would use instruction set the code does to execute to run the program. So that's what I'm saying. The touch will create the program, create the instance of the program because the touch command, the instructions is shared as almost basically the subroutines are branched, and the branch is what it takes whether the program starts or not. So this will launch a program. So I'm trying to create a program that when it's touched, or file, any file, say I want to so basically the touch represents the full command. And the full really have the command, you just need to view touch. So if I touch a file name or txt, I'm creating a new file. But if I'm touching a program that understands what the instruction set of touch is, like that understands what touch means, like it will perform some other operation because it's branched, because it recognizes as an instruction set. It basically uses a real principle. Our resource acquisition is initialization to initialize a process. Yeah. So that's the idea. So I hope I'm explaining this properly, but it's gonna be easier. Usually, it's like if you're on a low computing memory, like a CPU that's let's say 32-bit processor, the instruction sets and memory have commands, and commands that can overflow to 64-bit. So you'll know overflow to what's this problem in Game Boys, because it does happen in game, because you have to program 32 bits of you can only use 64-bit architecture. So if you're doing 32-bit processor, when you're 32-bit processor, you don't want 33-bit command because an overflow. See, you know what I'm saying. So x32 execution 32. So x32 and x64 are different processing structures. So that's my understanding. So you have that. You have a yeah. So for example, let me give you an example. Ping is network touch. So if you're online, the ping command will ping a domain, but you can use some touch command to create a domain to register the domain. Because touch and touch, if the program works, if the program is sane, if the program is not, I won't say sane, if the program works as intended, this won't be very erratic, this won't be very erratic, this will just be an instant open. This touch command is trying to go online. I'm trying to touch a domain. I'm trying to touch a domain name. So by touching my name, that will activate the ping command, because touch basically, if touch is offline, if ping is offline, say I'm pinging localhost, I can ping a local host, but I could also touch a local host. So I could also touch, but touch will work offline. Should work offline, but ping should ping online and offline, because it's the same concept of execution. So I tend to reverse, I have some code that understands this is instruction belongs to this category, and this one means to execute. So I call it so use alpha and beta reduction to as isotrophic proof of the instruction set is isotrophic. So like the alpha and beta reduction and alpha and beta isotrophism is used to register the command, used to apply the command, to call the command. Because the command is there. So if I have a file, if I have to delete a file, because touch can mean, if you have touch, there's the opposite, which is delete. I could just say touch the delete button, touch delete yeah. So basically, this file called .dat, which is a data file, basically you can run operation on data file. A program that has a data file in C can manage basically the DAT files, data files, configuration files, because they used to manage the program, but they have data in it, so they used to configure the DAT used to configure the DAT files. So I can't. The proof is very bad. All I just said is just like but uh that files that files data file used to store information use text, binary, or video configuration settings depending on creation applications. So if I touch, for example, if I touch file.dat, config.dat, is a general data container. So I can contain files. Basically, it stores configuration, text-based files, binary metadata, requires to create them properly. I think to read a text editor will show us garbage. This is called no mainstream. Yeah. So this is what I'm saying. So open with. So if you have basically, the idea is like you can run instructions, but the command is native, so it's like native to operating system, because it allows operating system to operate on the program, like a touch, or you want to have the ping program.exe, or like a ls program. This program can be used programmatically with the interface, that first one proof. So this is basically the tactile proof. So like any program I execute on the cybernetic interface, computationally is mapped to the have a isotrophism to the touch equivalence. So basically, if I want to touch if I touch my computer screen and I'm touching it, I'm literally touching it. It's not like you touch. It's not like you touch. And I want to create basically, I have a tactile command that's isotrophic to the digital command, and the command can run smoothly without any interference because it's cybernetic interface. So basically, it works with cybernetic interface. So it works with the tactile cybernetic interface. So, this example should use prove that basically I'm trying to prove isotrophism. Basically, yeah. So basically, the subroutine, the branch is if you have an if else branch, founding, if okay, so if not founding, founding basically, input so if arg0, arg0, arg1, if arg1, obviously I'm gonna write, I'm not even doing the command. So the define, let me define it. Def touch 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 a command. So it takes a command touch take a command or program. It takes touch inputs. Let's just call the input underscore cmd underscore command. So touch a command. Uh if command if type command is if type command uh basically I'm overthinking this, you see. If uh if type command is foul is foul basically this is one branch. Basically see this included, basically see this instruction set. Basically this is now specifically I could have defined label for this command. So this is like a label for this branch. This branch will be basically this branch will be the file name. So this branch will be a label. So if type command is file, the file name will be file file type file, or is file label is file uh uh go to is file. But this, Python doesn't have that syntax, so you have to basically. I can't label the branch, but the instruction set can basically only execute this is basically it only execute this instruction set and return. So if and then you go elif or like basically the labels, they have labels, and the labels are the thing that identify the code that the instruction set that will run. So basically when I hex dump, when I install this routine, which is a function, I get the branch, only get the branch because the branch is what's being executed. You know what I'm saying, so that's what I'm trying to build. So that's the first MVP because I'm trying to demonstrate that I'm trying to demonstrate astrophism, uh, and I hope it's useful, actually useful because I'll be using this, and alpha and beta reduction of problems, like shorthand, like shortcuts, like alpha and beta reduction as shortcuts or shorthand initializers, shorthand initialization, or shorthand resource acquisition is not resource acquisition is initialization. So basically, shorthand resource acquisition initialization is like a array concept. If you acquire a resource, you are either you are initializing it, and when you initialize it, it can be a form of execution. Well, it's not a position, unless it's explicitly is going to execute it. But the idea is you have the resource acquisition is show how equal resource utilization for associative basically. It's basically a function because it's not executed. It's an object. It's an object. It's all objects. It's like sort of object files. But it's like when you have some, say if it, so my other in concept, if you have an object file, if you have like a library, let's say it's a program.o, and this program is touched. It's now this touch now being executed. So this will now execute. So if I touch program.o, I'm running program, and this is how execute because it's an object file with a main. So I touch it, it records a touch command, and this touch command executes it. So it's now executed this program.o. So this one was an object file. So it will run temporarily and okay, unless you have a different command. So if you have a different command, you have let's say you have a ls program.o, and you're now running ls. Now this run a different, this is a different command. You have a different outcome, and that's also basically That's like so the object file like is literally a main is it's like a DLL. You can touch objects of DLL, but it's like you run instruction set based on what the program is stored, what the code is done. Because the commands register, if they are pure functions, they will not do they will perform the operation what the program tells them to, like a reverse proxy. Because it's basically gonna be in the buffer of the terminal. So you should get a hexadecimal. So hexadecimal. If you want to put dash hex dump, so yeah. So that's the idea. So if I have a touch program the O ls program the O, and this program prints I get, and then I push that I dot and I put on the hexadecimal dump, I get the isotrophism. And this will be alpha and beta reduced. So basically, it will be these are different kind of reduction, because one is based on design, one is based on data. So if I touch that dot o that will give me data, but because these are different programs. So that's what I'm trying to prove. If this doesn't work, then this is like a failure to me. So that doesn't work. So this astrophic program, astrophic in programming paradigms, because the instruction set are mapped to the. It's not just like it's not just explicitly defined. It basically has to be called by the program. And this is what I'm saying. This is what I'm trying to do. So it's basically for tactile interface. Thank you for watching this video. Tactile interface for tactile interface.